Hello everyone, my name is Deepak Deshmukh. Today we will see how to get model of spanner in Creo Parametric, and again we will see how to do analysis of that spanner in Ansys. So we can see here this is the spanner and various dimensions are given. It is in a 2D, that is two dimensional. Now we will create model of this spanner in 3D. So this is the window of Creo Parametrics. So click on the new. Again here you have to click on the part and subtype is a solid. So file name, give the proper file name. Here I am giving spanner. Again uncheck this use default template and say OK. So here are various templates, but suitable template is here MMNS part solid. So select MMNS part solid and say OK. Okay, so first we will sketch the image of spanner and then we will extrude that particular sketch. So I am first selecting sketch and here plane, there are various plane, we will select front and sketch. Okay. So normal it, so click on the normal button. Okay, so you can see here these 2 points, this point and these points are on this center line or this axis. So first we will mark these points on the horizontal axis. That's why I am drawing here center lines, this one and this one. Again I am marking this point here, so this point. Okay, now I am mirroring this point along this line, so I am selecting this mirror, select this line, this point will be here. Now dimensions, the distance between these 2 points is 280. So dimensioning, I am selecting these 2 points and this dimension is 280. So again you can see here with horizontals there is also another center line, and this center line is creating 15-degree angle. So again I am drawing two lines, this one and this one, and these two lines are parallel to each other. So I am selecting this parallel, this one and this one are parallel. This symbol indicating that this line is parallel to this line. Again this angle is 15 degree. So by clicking dimensions, click this one, again press the middle button of mouse and mention the angle here 15. So this is the 15 angle. You can see here from this point there is an arc having radius 54. So I am drawing one circle having radius 54. So I am drawing this circle from this point and its radius is 54. Again you can see here from this point there are two arcs having radius are 25 and radius 58. Again the distance between this point to this point is given here, it is 25. Okay, so I am drawing here circle somewhere here and its radius is 25. Again another circle from same point having radius 58. Again the distance between this point to this point is 25. So select these 2 points, dimension, give here dimension 25. Okay. Now delete the unwanted segments. From here click delete segment, and we don't want this. Again this one. Okay. Now join these two arcs by arc having radius R29. You can see here R29. So go here, right click the mouse button, select on this connect two entities with an arc. So first select this one, after that this one, this one. Okay. So again click right button and click on the equal sign. That is, these two curves are equal and having radius 29. So give the radius here 29. Now draw line like this. Make it parallel to center line. Okay. Again mirror it. Okay. So again delete unwanted segment by clicking here. So we don't want this one, again this one, this one, okay. So here distance is 46 between these two lines. The distance is 46. Dimension, click this line, this line, this line. This distance is 46. Okay. Again here is, now you can see here this angle is 10. So right click, select this arc, this one, this one, this one, this one, right click, make them equal, and this radius is 10. Okay, now this part is completed. Now we will start this part. So you can see here from this point there is a one circle or one arc having radius R50. So go here, select circle, select this point, and its radius is 50. Again from this point you can see there are two arcs having radius R23 and R56. Again distance between this point to this point is 23. So one radius is 23 and one is 56. So again draw circle from somewhere here, avoid the constraint. So its radius is 23. Again there is another circle, okay, and its radius is 20. 56. Okay, so this radius is 56. Okay, and again the distance between this point to this point is 23. So go in dimensioning, select this point, again this point, and this distance is 23. Okay, so now delete the unwanted segments. Delete segments. We don't want this part. Again we don't want this part. Okay, so delete this one also. Okay, now look at here, this radius is 26. So again go here, select this arc, select this line, again this line, and this line. That is this arc will be here and here, and its value is, I will first make it equal, that is the radius of these two arcs is equal. Okay, and its value is 26. Now draw one line, okay, from here to here. Okay, okay, so now make this line parallel to center line. So select this parallel, select this line and this line. Now it will be parallel to the center line. Again mirror it, select this line, mirror along this center line. So select this, so this will be the mirror line. Okay, now the distance between this line to this line, it is a 41. So dimensioning, select this line, and this is the 41. Okay, now delete the unwanted segments by selecting delete segments. So we don't want this portion, again this portion. Okay, now draw the last segment. So draw the line from here to here, and the distance between the center line to this line is 90. Okay, another line, avoid the constraints, from here to here, and again distance between this line to this line, it is 38. Now we have to draw this curve. Here we can see that here radius is R50 and here radius is 40. So select this curve, select this point, in this way. Again tangent here. Now make this line tangent to this line. So select tangent, select this line and this line. Again select this line and this line. Okay. So now this radius is 50. Okay. Similarly, this side also, select this arc from here to here. Again, make this line tangent. So select tangent, this line to this line. Again, this to this. Now it is tangent. Okay. Again, this radius is 40. Okay. Now delete the unwanted parts. So select this and delete this one. We don't want this and this. Okay. Similarly, this side also. Again, select arc from here to this line. Again, with the tangent, this line, this arc to this arc, and this arc to this arc. Okay. So select here dimension radius. So it is a, let's delete this one. So this is a, how much it is, radius is 30 and here 40. So this one is 30. Okay. Now similarly this side also. Make a tangent, this arc to this line and this arc to this line. Now this radius is 40 and this one is 40. Okay. So now again delete unwanted segment. We don't want this one and this one. Okay, our part is almost ready. Okay, so last part, this part is only remain. So we will draw this part. Select this center rectangle. Select center point. Okay, so this length is 175 and this one is 18. Okay, now select circle from here to here. Again from here to here, draw circle. Okay, so now delete unwanted part. We don't want these. 1 minute, control Z. Select delete segment, select properly. This one, this one, this one, this one. Okay. Again this side, this one and this one. Okay. Okay, this dimension is weak dimension, so make it strong. Just click on it and go here and click on it. Its color is blue. Now its color is blue, but after clicking here can make it strong. Now it's strong. Okay, now our part is ready. So click here. This is our part. Now here confirm the sketch region, that is the sketch region. We are extruding, we are selecting the sketch region. So first we will select this one, press Ctrl and hold it, and again click here. These two parts are similar, so we will do similar operation here and say extrude. Okay, here select symmetric and this length is a 16. Okay, and say okay. Okay, now this part is ready. Okay, now select this one, again extrude, make it symmetric, and this length is 8. And say okay. Okay, so last part is this one, so select this one, extrude, again do same procedure, make it symmetric, and the only change is the dimension, it is 4. Enter and say okay. Okay, so this is our spanner, and the only remaining part is to do round, take a round. So I am doing here auto round. Again here I will select radius 2 and say okay. So this is our spanner. Now I am saving this file, save as, save copy. Just change the type of the part. I am selecting here the step file so that I can open this spanner model into the Ansys. Now I am opening Ansys. Well, this is the Ansys window. Here we can see various types of analysis. But for this type of part, we are going to select static structural. So double click on this static structural. Okay. Here you can see various options, that engineering, data, geometry, model, setup, solution, and result. So from first one, that is engineering data, we are going to select the material of the spanner. For this spanner, we are going to select the material structural steel. So these are the properties of material structural steel. That is, you can see here density, again Young's modulus, Poisson's ratio, bulk modulus, shear modulus. These are all the properties of that structural steel. Also, you can change the unit from here. Again, if you want to change the material, you can select the material, or you can define the material from here. Click here to add a new material. So by clicking here, you can add here new material. Again, you have to define these properties. You can define from here, giving the new value. But for this part, we are going to select the structural steel material. So I am keeping this structural steel as a material of this spanner. Now I will change the unit from here. So I am my dimensions are in mm, so I am using this metric ton mm, that type of unit. Okay, so now into projects. Now what I will do, on this second option, that is geometry, I will import the geometry. So go here, just right click here and wait for some times. So here you can see the option import geometry. So you can browse the particular file. So I am browsing this file. Okay, so here I will put the name, that is the spanner. Okay, spanner. This is the file spanner. It have the extension .stp. So this type of file will open in Ansys. So already I have saved this file as a stp extension. So open. Okay, this tick mark shows that particular geometry is selected. So now I'm going to this third option, that is model. We'll go here, or right click or double click. I will just double click here, or you can also right click here, and you can say here edit. Again, it is taking some time. It's depend on our RAM of the laptop or PC. Okay, our geometry is, so you can see geometry here. This is our geometry. Now we are going to mesh it, that is, we are going to discretize this part into the finite element. That is, we are going to make its elements. That is, by using the command mesh, we are going to discretize this particular part, so that our infinite number of elements will convert into the finite numbers. If someone says how many elements are here, then at current time I cannot say how many elements are here, but I can generate the finite element by using the mesh, and then I can say how much elements are here. So I am generating the mesh. That is, you should go here, just go here, right click here and say generate mesh. Okay, you can see the progress here. Mesh in progress. Okay, so it's over now. So this is the meshing, that is, we discretized this part into the finite number of elements. Okay, so if you want to check the how many elements are here, so you can see here total elements are 6,691, and again nodes are 12,582. So this particular, this triangular shape is nothing but the element. So if you count this total triangulars, then it will be 6691, and if you count that particular points, it is called as node. So that's nodes are 12,582. So this is our mesh. Again, you can modify mesh by using the sizing. uh, Again, you can change the element type, uh, etc. So now next we will see, suppose we are holding the nut or bolt by these sides, and again we are applying force to this side. So we are fixing these faces. Why we are fixing? Because we know that if this particular face will be in contact with the nut or bolt, so its relative motion uh, is 0. That is, we can consider these faces as a fixed faces. Okay, so first we are that is called as boundary conditions. We are going to apply the boundary conditions here. That is, we are going to fix these faces. So I'm going here, static structural. Just right click here, and again insert. Here you can see fixed supports. So I'm clicking here, fixed supports, and now I'm selecting the faces here. So I want to fix these faces inside of this particular portion. So I am selecting it, select it, just press and hold Control key, select other faces so that we can select simultaneously other faces also. So again this one, again this one, and this one. Okay, then say apply. Total 5 faces we can see here. This blue color zone is fixed now. Okay, so total faces are 5 and that faces are fixed. Okay, again we are going to apply force to this side. Suppose we are holding this spanner from this side and applying force in this direction. Suppose nut is here, we are holding this spanner here and applying force in this direction. So again I am applying the boundary condition here. Just go here, static structural, right click here, insert. I am applying pressure force here. Pressure force is normal, always normal to the surface. So if I select the surface here, suppose this one, again press and hold Control key, this one, and this one. Okay, and if I say apply, what will happen? The force will apply normal to that particular surface. Okay, so I am saying apply. Again I am putting here a value. Suppose it is 10 megapascal. So I am putting here 10 megapascal. Okay. So these are the boundary conditions. We fixed this face. Again we apply force to this side. Now I am going to the solution. Just go and right click here in insert. What I want actually as a result, I want stress and deformation, or you can select anything from here. So now I want the stress, so I am going stress. In that there are again various types of stress, so I want one message stresses, so I am clicking here. Okay, again I want deformation. Okay, so here I want total deformation, so I am selecting this total deformations. Okay, So now the last step is the solution, that is solve. So go here, solution, same process, right click and say solve. For the solution again it's going to take a lot of time. You can see the progress here, 10%. Okay, you can see here at this portion maximum stress is here. Blue color showing the less stress, or even it is near about zero stress. And if we go outside, this color shift, we can see this is the increase of the stresses. Okay, if you want to see the simulation, just go here, animation, and click here. You can see the simulation here, that is stress generated in this body. So you can see here stress is maximum. Okay, and blue portion particular shows the minimum stress or almost zero stress. Okay, so this is the stress and you can see the value here. Again, if you want to see the total deformation, just go here and click on here. Okay, so you can see that this portion is fixed as there, so it will not move. But if I apply the force here, so that portion, this portion, that is red color, is showing that the maximum shift, that is maximum deformation. Okay, if you see the animation here, this is the animation. So this portion is have maximum deformation. Okay, so you can see here the values of the deformations. This one is almost 9.02, so that it's up to 9. This portion is shifting almost 9 mm. Okay, so in this way we can see the analysis of various parts in the Ansys. Okay, thank you friends.